Alright, looks like we're recording now. So we got Scratch open, and here are the slides. So this one's about loops. So that's code that comes back around on itself. Remember that repeat block? We were using that. We're going to do a bit more of that today. Okay? So, yeah. We're eventually going to be using blocks that require conditions just like the if-else blocks needed. Okay? So loops. That is our goal for the day. And what that is, right, it's you have some code. It runs in order, as usual. But we would like it to do this. We would like it to wrap back around and repeat a bunch of times. Let me mute my sound so you can join and I can't hear it. So you could repeat this as many times as you want, and then eventually it'll hopefully stop, because your program is supposed to stop. So we learned how to do that one way. We learned how to repeat a certain number of times with the repeat blank times block. Remember that? Looked like this. It was like repeat, and then you put a number here, n times, and it will run the code in between here as many times as you asked it to. And this, I think I said this for the if-else block, but like the piece inside this part of this loop block that takes other code, it's called the body. It's like this is the head, down here is the legs. The middle part, the interesting part, the code that you want to repeat, that's called the body of this block. Okay? So the body for the repeat block is going to get repeated n times, whatever that n is. Body gets repeated n times. Okay? So that's how that works. And yeah, there's plenty other loops. There are more where those came from. It's down here in control, right? You got your repeat, you have a forever block, ooh, and then there's also a repeat until block that takes a condition. You see how it's pointy? Hopefully it's a little small, sorry. Hopefully you're on Zoom watching me too. But those are some interesting blocks as well. So, alright, so let's just spell it all out. A loop, right? It's a block that keeps getting run. The body of it keeps getting run as much as you want. You can specify how many times you want that body to run, or you can just say, I want to make that body run forever. You can use the forever block for that. Your program will never stop. It will keep on repeating until the end of time, forever. So this block right here. See how there's no room to put any numbers or anything? Repeat how many times? Infinity times. All right? So the forever block keeps running its body forever. Keeps running forever. Oops. So that's pretty nice. Otherwise, you can use a repeat block if you had a certain number of times. So yeah, it's the inside, that body part that is running repeatedly. And I call each time it runs that body, I call that an iteration of the loop. That's just a fancy Latin word that comes from like the verb to go. So like it's going through all this code inside here once. It's called an iteration. So loops iterate, and one iteration is passed, 2 iterations is passed, things like that. I'll say those words. Yeah, there's also a repeat until block. That's this one. This is probably the most generic, the most useful one here. It'll take a while to explain though. It takes a condition. Repeat until some condition becomes true. Okay? So repeat until keeps repeating until a certain Boolean condition, whatever you want to make, becomes true. So repeat until, and then it has a spot for a pointy thing, which is a condition, something that gives back true or false. That's your con from last time, right? Your condition goes there, and then it keeps on repeating its body until that condition is true. Repeat until cond is true. And so eventually, like it's going to start out false, hopefully, and it'll run a few times, and eventually that'll change the condition. The condition will eventually turn into true after a few times being false. Right? So those are the blocks. This one's a little difficult to grasp, I think, and I'll give examples. But are there any questions about any of these words, any of these drawings, before I give you actual code? All right, so here's my silly example. Let's have a scratch cat that just bounces forever and ever. So we'll use a forever block. So let's have the green flag start the program. So when the green flag gets clicked, let's, I don't know, let's change the the direction of the scratch cat, so he's kind of interesting. Or I'll just keep him like this for now. Forever. What do I want him to do? I'd like him to move 10 steps in his current position, so like just keep on walking forward. And then eventually, right, he's going to hit the wall. If he walks enough times, he's going to hit the wall. So if he ever hits the wall, I want him to bounce off of the wall. So there's this cute little if on edge bounce block right here in motion. If I just put that underneath, it's like move a little bit if you can. If you just bumped into the wall, bounce off of it. Change your direction, please. And so forever, I want to do these 2 blocks until the end of time. So move a little bit, bounce if you hit a wall. Move a little bit, bounce if you hit a wall. And if you do that enough times fast, it's animated, right? Whee, there he goes. So he's just going left and right now, and that's because this direction is perfectly perfectly horizontal. If I change his starting direction a little bit, I start the program like, if I make him go this way or something, then he'll shoot off and do more interesting things. But yeah, it's just move 10 steps. If you're on the edge, bounce, and this program never stops. This is a forever loop. It keeps repeating these 2 blue blocks inside of it. That's the body. It's going to run forever until the end of time, until I press the stop sign. Okay? Any questions about this code? Does that make enough sense? A loop is something that keeps getting run. A forever loop is something that never stops being run unless you stop it. So let me save that for us. Give that to you later. All right, so that's not too bad. Let's do something slightly fancier now. Let's make a program that doesn't do any animation, but computes a number. That's what computers were meant to do, right? So let's make a program that sums up all the numbers from 1 to 10. Okay, and I'll show you how I do that. So let's see. Yeah. So here's the style. All right, I'm going to use 2 variables. Right, I'm going to need 2 variables to make this work. I'm going to need a variable called sum. And I'll start off at 0. And the idea is I'm going to put 1 in here. I'm going to add 1 into sum, then 2 into sum, then 3 into sum, then 4 into sum, all the way to 10. And after I've done all 10 numbers, I will have the sum of 1 to 10 in the sum variable. All right. So how do I shove the numbers 1 to 10 in it? Well, here's what we need to do. So we're going to start off. We need that variable to hold the answer eventually. And so we want to start it off at 0. So it's like going to hold exactly what we put in there, no more, no less, no offsets. And then I'm going to add 1 into sum, then 2, then 3, then all the way to 10. And then it'll hold the answer. But what is this? You see all these bullets? Like add something into sum, add something into sum, add something into sum. Those are repetitive things. These bullets are repetitive. Repetitive. So whenever you see repetition in your little algorithms, that should scream loop in your mind. I should turn that into a loop somehow. All right? And so here's how you do it. If you'd like to make this into a loop, you need to do the same thing a bunch of times. How do you make the number change and still do the same thing? You use a variable. All right? So I'll use a second variable to keep track of what number I'm currently trying to add into the sum variable. I'll call it, I don't know, to add. And I'll start it at 1. That's the first number I'd like to place into the sum variable. Okay? So here's the game. Here's what's going to happen with these 2 variables. Sum starts at 0, to add starts at 1. I'm going to keep adding the current value of to add into sum. So now sum is equal to itself plus to add, so 1. And then I'm going to increment to add. Now it's ready to add the number 2 into sum. And then I'll loop. Add whatever's in to add now into sum, please. And so it's going to add the 2. 1 plus 2 is 3. See how it's building up the answer? Then I'll increment to add again. Make it 3. Add that into sum now. All right, so it's still the same thing. It's all the same code. It's add whatever is in to add into sum. That's how you can loop. So now it's 6, right? Because 3 plus 3 is 6. Then make it 4. Add the 4 in. Now it's 10. And eventually, we'll get all the way to the right answer. And I think it's like 55 or something. So, yeah, that's the game plan, right? And then once we're done with all this, we'll stop the loop and then print out whatever is in sum because it'll have the sum from 1 to 10 at that point. Okay? Does that idea make sense to us? I can make all these bullets the same piece of code by just saying put whatever is in to add into sum and then increment to add because now it's ready for the next round. Add the next bigger number. All right. So let's see here. Oh, I was supposed to do this ahead of time. There. So let me make the code, and then I'll draw what happens. All right. First, we'll use a repeat block, a repeat 10 block, and then we'll use the repeat until, which is probably the right way to do it. All right. So how do we do that? Make a new program. Sure. Or actually, let's get rid of that. When the green flag is clicked, what do I want to have happen? Well, I need some variables first, so I'll rename this default variable to sum. I'll make a new variable called toAdd, right? Those are the ones that I needed. I can show their values, that's fine. Let's see what else. Yeah, that's all. So those are the two variables I need. I need sum to start at 0 and toAdd to start at 1, right? That was how that game began. So at the very beginning of the program, set sum to 0, set toAdd to 1, because that's the first number I want to put into sum, right? And then 10 times, right? 10 times I want to add the current value of toAdd into sum and increment toAdd, right? So let's use a repeat 10 block. That's the easiest way to think about it. So 10 times I want to do the following. I would like to set sum to be whatever it is plus the value that's in toAdd, right? Because eventually, like, it'll be first 1, then 2, then 3, then 4, and we'll keep adding whatever that is into sum, building up that answer slowly but surely. So the first thing, set sum to be the addition, in operators, the addition of whatever is currently in sum and the toAdd variable. Like right now it's 1, next time it'll be 2, right? So repeatedly do this, but we're not done repeating, because the next time we come back around and run this body, I want to add the number 2 into sum, and then the number 3 next. So to get ready for the next round, I want to also change toAdd by 1. That increments it by 1. Okay? That's the idea. And then just to be able to watch it change, I'm going to add a pausing block. I'll add a, where is it? I'll add a wait 1 second block. This is unnecessary, but it'll just allow us to watch the values change up here. All right. So see if you can like get on Zoom or just squint. Maybe you brought a telescope. Look at the screen at these tiny variable values and watch them change. Sum is 1, 3, toAdd's now 4. I'm going to put the 4 in, put the 5 in, put the 6 in, put the 7 in, 28, 36, 45. Yay, and now it's 55, and toAdd is 11. That's the last thing that happens. But the sum is the right answer. The sum is holding 55 now. So it kept on putting whatever was in toAdd into sum, set sum to be sum plus toAdd, and then change it by 1. All right? Does that make sense? Are there any questions about that? That's what's going on. Question? Yeah. What do you mean you're not getting it? You're not seeing it? Oh, to see it, you have to check it over here. Yeah, or you could just print it out. You can have the Scratch Cat say it too. That's another way to do it. Any other questions? Yeah.
In Scratch, is there any meaningful difference between set sum to existing sum plus toAdd and changing sum by the value of toAdd?
No, it should be the same thing. I just want to show you both options. Yeah, good question. Change just means increment it by this value, and if it's a negative value, it'll decrement it. Yeah, good question. All right. And then once he's done working on all this stuff, I guess we can have him just say the answer, all big, say sum for 2 seconds or something. So that's one way to do it. Next, I want to use a repeat until block to get you practice with that. And so, yay, 55 is the answer, and he says it. So I'll save this, and then let's change a little bit. I'm going to change it to use a repeat until block instead of a repeat 10 block. Okay, so now we have to think about a condition. Not just do this 10 times, repeat until something is true. All right, so let me do some surgery here. Going to make the repeat until block this. It's going to have this body. I'm going to get rid of the repeat 10. And now the question is, what condition do I put here? When do I want this to be true? I want it to be true when I don't want to repeat anymore, right? Repeat until this thing is true. So we have to think about this. The right answer is, well, toAdd is 1, then toAdd is 2, then toAdd is 3. I want to keep repeating adding to add into sum as long as to add is a number that I want to put into sum, right? So the second it gets bigger than 10, because it's eventually going to get large, right? The second to add gets bigger than 10, I want to stop this loop because I don't want to put anything bigger than 10 into sum, right? I want to only go up to 10. Once it's 11, I'm done. So that is the right condition here. You can think of others, but this is probably the easiest one. So while, repeat until sum is greater than 10. To add, sorry, is greater than 10. Let's see here. To add is greater than the number 10. That's the idea. Okay? So this again will work, and then I'll draw why it's working in just a second. But it's going to do the right thing in theory. It says 55, and that is the right answer. And to add the very last time, to add is 11. We don't want to add 11 in. That's what stops this repeat until block. That's what stops the loop. Okay? So, are there any questions about this before I draw what's happening? Does it make enough sense? So here's what's going on. So at the very start, I set sum and to add to 0 and 1. Sum is 0. To add is 1. All right, and then we go into the loop. Repeat until to add is greater than 10. So is to add greater than 10? Is 1 greater than 10? No, it's not. So I'm going to continue. I'm going to run the body of this loop. I'm only doing this as long as this is false, right? Repeat until this is true. Stop once it is. It's not yet true. So I'm going to set sum to be whatever sum plus to add is. So sum plus to add, 0 plus 1 is 1. I'm going to put 1 into sum, right? And then I'm going to change to add by 1, which increments it to 2. And then I wait a second, right? And then I come back around and check this condition again, because I'm repeating all these three things until to add is greater than 10. To add is still not greater than 10, right? So I'm going to run the body again. Put the 2 into sum now. Change sum, or set sum to be sum plus to add. So put the 2 into sum. Sum plus to add is 1 plus 2 is 3. So put 3 into sum, and then increment to add. Okay? Wait a second. Then we come back and check the condition. Do I still want to do this loop? Repeat all of this until to add is greater than 10. To add is still less than 10. So we're good. Let's keep continuing with these 3 blocks. All right? So now it's 6 and 4, and wait a second. And I think you get the idea at this point, right? It's going to be 10 and 5, and then dot, 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 until like this gets to be 10, right? To add is 10, and the answer is 45 before it's 55, right? So now we come back around, repeat until to add is greater than 10. So to add right now is 10. Is 10 greater than 10? No, it's equal to, not yet. So we're going to run that body again. This will be the last time though. So we set sum to be whatever sum is plus to add, so that makes it 55, which is our final answer. And we change to add by 1, making it 11. And that's going to stop our loop. Wait a second. Now we come right back. Do we still want to repeat? Repeat until to add is greater than 10. Is 11 greater than 10? It is. So that is my stopping condition. I want to stop the loop now. It's done. Now I come back out. I've continued after the loop, and I say sum for 2 seconds. That's why to add at the very end is 11. That's what stops the loop, right? So we stop when to add is greater than 10, right? That's the idea. And so that's why it also works if you say repeat 10 as well. Repeat 10 also works for the same reason. Either way. Any questions about that? Does that make sense? That's the idea. So, I don't know. Here's this code. Here's my problem for you now. Take a few minutes to say hi to your neighbors and help each other. Instead of adding all the numbers from 1 to 10, write some code to add all the numbers from 1 to 25, but only the odd ones. I want you to add only the odd numbers from 1 to 25. Does the question make sense? Figure out what that answer is. Change this code up to give that one back. Okay? I'll give you a few minutes to try that and yell at me if you have any questions. Help each other. So you'll still need sum and to add, but they're going to change in different ways, aren't they? They're going to stop at different places. That's another way to do it. That's one variable. That works too. Oh, or wait, no, you're not adding the right numbers. Sorry, you're adding. That means you're adding a multiple of 2 each time. So it's like just counting by 2s. You're not adding them into sums. Because like the first time it's 1, then sum should be 4 after that, then it should be 9 after that, and then it should be 16 after that. You're just counting by 2s right now. Yeah. So that wouldn't work. Sorry. No. You do need that extra variable. My bad. Alright, that's my timer. Do any brave souls want to share how they got it? You can keep all this code. What needs to change, though? Did anybody find it? Yeah, so we want to keep going after we're greater than 10, right? We want to stop once we get bigger than 25. Good. So that should change to 25. And then what else? There's one more thing that needs to change. Anybody find it? Yeah, I don't want to add by 1 because I don't add 1 plus 2 plus 3. I want to add 1, 3, 5. So it needs to change every 2. It needs to change 2 at a time. Good. Does that make sense why that's going to do the right thing? Like here's 2 add. It'll start at 1, then it'll become 3 because we're changing it by 2. then it'll be 5, then it'll be 7, then it'll be 9, all the way to 25. I want to keep the 25 and add it. And then one last time it'll be made to be 27, and we don't want to add 27 in. So we repeat until it's greater than 25. It stops whenever it gets bigger. We don't put that into our sum variable. Okay? Any questions about that? That's how you add a bunch of numbers together. It's probably why computers exist. So I'll save that, give it to you later. Yeah, are we good to move on? More loopy topics. I do want to combine loops and other blocks now. Here's my silly example. Probably works out better in the fall when it's close to Halloween, but let's just pretend it's close to Halloween. I'm going to make a program about ghosts, all right? And it will prove to you, hopefully, that Boolean operations are great, and you should love them forever. Okay, so here's the idea. I'm going to make a silly program where we're going to ask the user if they believe in ghosts. And if they do, some ghosts will appear. Otherwise, they will not appear. Okay, that's my silly idea. So, yeah, if they say that they do believe in ghosts, we're going to use a variable to have the ghosts who are snooping around know when to show themselves. So I'm going to make a variable called should_show_ghosts. And I'm going to start it at like 0 for no and 1 for yes. So we'll start it at 0 because we don't know what the user thinks yet. And then if they say they do believe in ghosts, we'll change it from a 0 to a 1. Otherwise, we'll keep it at 0. And the ghosts will be summoned if should_show_ghosts ever changes to be the number 1. Okay? They're just going to keep watching that variable, and they will awaken themselves. They'll make themselves visible when the user says the right thing. Okay, so that's my silly program. Let me make it for you. Let's set the scene. All right, we need a scary backdrop. I think there's like a woods backdrop. There we go, extra scary. We need some ghosts. I think there is a legitimate ghost sprite. Let's have 3 ghosts. I don't know, a bat's scary. That can be 1 ghost. We could have, what else? Ghost. We have an actual ghost, and I think there's a skeleton too, so let's have that one. You can, of course, pick whatever scary things you want, but I'm going to have 3 ghosts. Here they all are. We have the ghost, the skeleton, and the bat. Very scary and spooky. Okay, so those are my 3 ghosts, and I want to start them out hidden and watching this value of this variable. So I have planned to call it should_show_ghosts. You can have variables with spaces in them in Scratch, but in every other programming language you can't. So I'm going to use underscores just to get you in that mood. Other programming languages. Should_show_ghosts. That will be our variable that the ghosts will be watching. Okay, so let's have the asking happen at the Scratch Cats program. So can I move this at all? Yeah, there we go. So sprite 1, you are the Scratch Cat. Excuse you. So this is the Scratch Cats program right now. He's the one who's going to ask, do you believe in ghosts? Right? So let's see, where is that? Was it down here in sensing? I always forget. There it is. So ask, what's your name, and wait. No. Ask, do you believe in ghosts? And wait. And the answer is going to be either yes or no, right? And here's what I'm going to do. If they say that they do believe in ghosts, if their answer is yes, then I'm going to change the should_show_ghosts variable to 1. Otherwise, I'm going to set it to 0. Okay? And I should start it at 0. 0 for false. Just so that the ghosts don't show themselves at the beginning. Because they're going to be watching this variable. That's the plan. Ghosts should hide themselves at the start of the program. Okay, so set it to 0 at the beginning, and then we're going to ask and wait. And now in answer, we have yes or no. And so depending on what the user typed, we're going to set that should_show_ghosts variable to either 1 or 0, and we're going to use that variable in the programs for the 3 ghosts. to show themselves or hide themselves. Okay, that's going to be our game plan. So if the answer is yes, then we should set the should show ghosts variable to a 0, otherwise it's a 1. Right, so if the answer is equal to yes, then we're going to change the should show ghosts variable to a 1 for true, right? And then otherwise we'll keep it at 0. Technically I don't even need an else case because we started it at 0, but just for fun, we'll have it there. All right, so does that make sense? That's the Scratch Cats program. And so now, let's see here. Let me just put it outside here. Do you believe in ghosts? If I say no, should show ghosts to 0, and it stayed 0. But if I say, do you believe in ghosts? Yes. Now should show ghosts is set to 1. And we can use that change to alert these ghosts over here to do different things. Okay, does that all make sense to us? Any questions about the setup? Because now we have to hook the other ghosts into that variable. They have to keep watching it now. All right, so they're going to get, what's the plan? They're going to be summoned depending on the value of that should show ghosts variable. And so that just means they're just going to keep watching it. Does it change? Did it change now? Did it change now? Did it change now? They'll just keep watching it forever. And so we're going to need a forever loop. Forever, Mr. Ghosts, please keep watching. Watching the should show ghosts variable. Hide yourself or show yourself depending. Right? So now I'm going to click over to the bats program. I'm going to make a program for the bat. When the program begins, as far as the bat is concerned, he needs to keep watching the value of the should show ghosts variable forever, right? Forever. I need to do the following. I'll do it outside, then I'll put it in the loop. So what needs to happen every split second for the bat? He needs to keep watching the value of that should show ghosts variable. If it's ever a 1, then he needs to show himself. Otherwise, he needs to hide himself. Yeah? So if should show ghosts ever becomes 1, if it's set to 1, then the bat better show himself. And that is, I assume it's in looks. Show. Otherwise, it was set to non-1, so it's set to 0. And the bat should hide himself. And so this needs to happen every split second because we don't know when the user is going to finish typing. Right? He needs to keep checking this forever and ever until the end of time. So forever, keep doing that. Oops. If this is true, show, otherwise hide. Does that make sense? So every split second, forever, until the end of time, check this should show ghost variable. If it changed to 1, show yourself, otherwise keep hiding yourself. Okay? Any questions about that? It's a weird little thing, but we have an if inside of the forever now. And I hope it makes sense. Forever, keep checking this. Forever, until the end of time. Okay? That's what needs to happen. So this program needs to work for the bat and the ghost and the skeleton. So I'm going to give this same program to the other 2 ghost sprites. And you can do that by dragging the program into their sprite. It kind of wiggles. And so now the ghost has it too. And I can do the same thing for skeleton. He wiggles. And now they all have the same program that's going to keep checking the should show ghosts variable and show or hide depending on its value. Okay? So let me run the program now. Do you believe in ghosts? Look at how they hid themselves at the start of the program as well. Beautiful, because they're watching that. If I say no, nothing happens. Right? Nothing happens. And also the program isn't over. You see how I have the option to click the stop? It's because the forever loop is still running in each of these 3 sprites. It's like, maybe it's going to change. I don't know. They're just still watching that value of that variable. And so I said no, they stayed hidden. If I try it again, and I say yes, do you believe in ghosts? Yes. Look at them. They're displayed. They come alive. So I think we understand the Scratch Cats version of the program. Let's go to the Ghosts program. All right. Here's what it's doing. At the very start of the program, we're setting should show ghosts to 0, right? And so he sees that forever. At the very start, he sees that should show ghosts is not set to 1, so he goes to the else and hides himself. All the ghosts do that. And if I say yes, I do believe in ghosts, that's going to change the should show ghosts variable to 1, right? And then this condition will be true, and it will run the show block, and it will just keep running the show block until the end of time, right? So it's just watching the value of that variable, because any split second it might change. Okay? Any questions about these 2 programs, the Scratch Cats program or the program that lives in all the ghosts? Does it make sense how that's working?
Wait 1 second before the firm starts on the ghost. Are they gonna actually be visible for 1 second and then?
There will. It depends on when you click enter, because they're going to be waiting, and then the Scratch Cat is asking you a question, and so every 1 second it's going to check now, and it pauses for a second. And so if you press enter right before they check and their 1 second is up, then it's going to be immediate. Otherwise, there will be at most a 1 second delay in them hiding themselves. Yeah, very good. Any other questions? And I encourage you to try that. See what happens. So that's that. Let me just walk you through, just in words, what's going on here. So I entered my answer, right, and that changed the answer variable to either yes or whatever else I typed, and I'm checking that. If it's equal to yes, then I'm changing the variable to a 1, otherwise I'm changing it to a 0, and it's the value of that answer variable that is driving this if block, and then that's going to change the should show ghosts variable, okay? That sets its value, and then each ghost is checking the should show ghosts variable forever and ever. Every split second, they're checking, does it have a new value? Does it have a new value? And either they're hiding or showing themselves constantly, depending on that value. Okay, so technically, if you were able to change should show ghosts very quickly and have it like flip back and forth, you would see the ghosts flicker. So that's kind of cool. I don't know if I even want to show you that, but why not? Let's get rid of all the asking and let's be like forever. I'm not gonna save this. It's just a cool idea. Forever. Let's have that value flicker. Let's set should show ghost to either 0 or 1, to a random number between 0 or 1. So each time I click this, it's a random number, 6, 9, 3, 2. Between 0 and 1. Then I'll undo all of this. And then wait a second. I don't know. I can see it like this. I think I need to make it wait for a little bit. But yeah, it's just watching. All the ghosts are continuously watching that variable. So, I don't know. Wait a quarter of a second or something. Set it to a random value. And now they're just going to flicker. Sometimes longer than others. So they're just watching that variable. And if it changes, they're going to either show or hide themselves. I don't know if this is cool to you, so I'll give you this program too, but I'll load the other one. Yeah.
What does it change? What is it like a
Because it's either setting it to a 0 or 1, the should show ghost variable. Sometimes it sets it to 0 twice, 3 times in a row, because it's random. It could be a streak of 0s or 1s, so it stays there longer than other times. Yeah. Good questions. So let's make it how it used to be. Load. Let's see, it's going to be downloads. This one. Replace. All right, here's the old version, and this is the one I want you to do something with. Okay, so here is my next question to you, and I can change this to be whatever program you want to see. Maybe I'll just give you them both right now or something. Here's this one. I know, I'll just leave it open. It's fine. No, I think it's easier this way because you can see the idea as well. So what I'd like you to do, I'll give you a few minutes to try it. Recreate this example if you haven't already. Here are the blocks. And change it up a little bit. I want you to explore. You can make it flicker again. Maybe you can make all the ghosts say boo when they appear. Just do something different so that you get some practice with this idea. Okay? And here are my tiny versions of these programs if you want to come up and look at them. But take my ghost example and tweak it a little bit. See what you can change, and that's going to really help you as a programmer. Okay? So try to write the coolest programming you can, and I'll give you a few minutes to do it. All right? Help each other. And we all did attendance, right? Can I stop that? I'll give you a minute if you forgot. Yeah. Okay. Well, as long as you said you were here today, I'll drop you if you say it 3 times. If you weren't here 3 times consecutively. So I don't think it's a problem as long as you signed in today. All right, I'm stopping attendance now. A few more minutes to play around. That's really how you learn. Take your time. All right. There'll be plenty more time to play around with that, but I want to keep moving for now. Hopefully you got something cool. All right, for my last trick of the day, before I talk about your next assignment, I want to talk to you about how to make a little game, a platformer game. You know, things like Super Mario, stuff like this, where like you're moving sideways and jumping and stuff. It's called a platformer game because you have these little platforms that you can jump on and like run across. So like you could go up here if you want. Apparently that's why they call them platformers. Let's make our own in Scratch. So let's figure out how to do all these things. We need to be able to move, like with the arrow keys, move horizontally, jump, interact with things. So let's figure out how to make all that happen. Let's see. I will make a. I'll just keep the program blank for now, but there are multiple events that happen when keys get pressed, so I can have something happen when the left key gets pressed, left arrow, and the right arrow gets pressed, and that can move my cat, right? left and right. So what is, let's see, how do I want to do this? How do you move horizontally? Well, you can move in the current direction by saying move 10 steps. That just takes your current direction. But if I only want the Scratch Cat to move left and right, probably the easiest way to do that would be to change his X coordinate only. You see how the X coordinate is where you are horizontally, and the Y coordinate is where you are vertically? Just watch them change as you move it. If I just mess with the Scratch Cat's X coordinate, that's going to move him left and right. Does that make sense? If I change X by 10, that's positive X. That's the wrong way. That's the right way, right? If I make X bigger, that's to the right, right? On a number line, on a coordinate system. So that will make him move right. And if I change X by negative 10, that'll make the Scratch Cat move to the left. Changes X coordinate by negative 10. And so now these are events, and I can press the left arrow. I can press the right arrow, and he moves left and right. You can hold him in. It's fine. And then he kind of like moonwalks left and right. So that's useful. That's the inner workings of the start of a game. Does that make sense? These are just events. Press the left arrow, do this. Press the right arrow, do that. And if you hold it in, it'll just keep on doing the same thing. That's pretty easy. Let's see. What next? We also need to make him jump. So jumping, usually, like that's the space key in some games. Let's keep that going. So the space key will make the Scratch Cat jump. And how do you jump? We need to make him go up, right? How do you make the Scratch Cat go up? You need to change his Y value by some giant amount. Okay, so when he jumps, we need to change his Y value, not his X value. That's up, right? Positive Y. That's towards the sky. So change Y by not 10, but I don't know. How about 100? Maybe 150. I'm not sure. We'll find a good value. So he's here. I'm going to press the space key, and he jumps. We also want him to fall back down, right? We want him to fall back down to, maybe I'll make it 150. Because right now, if I just make him jump, like he stays in the air there. Like, he can only go up so far. We want him to jump up and then fall back down, like simulate gravity. So here's how you do that. Just make him teleport up really quickly by changing the Y, and then change the Y back down slowly, animate him falling. Okay? That's the idea. So we'll bring him back slowly until he touches the ground. We can do that with a loop. So just animate him falling by changing Y slowly in the negative direction. So if he went up, that's a positive 150 change. We need to bring him down a negative 150 change back to the ground. All right? So I'm going to change Y by negative 10 15 times. That'll bring him back to where he started, right? So I'm going to repeat this 15 times. So bring him up immediately 150 units, and then bring him down 150 units slowly animated. That's what the repetition does. Whee! So there he goes. Isn't that cool? You can make him jump up higher if this is not big enough for you, like make him go up 200 units. And make sure to bring him down 200 units too, right? So he ends up back where he starts. So now he can move left, move right, and he jumps. And he falls slowly. Isn't that fun? Are there any questions about these three things? Does it make sense why this all works? And these are just events. Key presses are events. And while he's falling, like you can make him move a little bit to the left and to the right if you press the keys. Like those programs, they'll run at the same time. There's different events. Okay? We're good with that? So here's my silly platformer game. Let's make the Scratch Cat, like let's pretend he's underwater, and we'll make him jump up and collect fish because cats love fish, right? So let's set the scene. Underwater 1 or 2. Let's do underwater 1. And then we want the Scratch Cat to jump up and collect fish. So let's add a fish sprite. Nemo. Okay, so here's the fish that the Scratch Cat will jump up and collect. Alright, so that will be the game. We're going to have him jump up, collect the fish, and every time he collects the fish, like a coin or something, we'll make his points go up. So we'll add a points variable or something. We'll gain a point every time he touches a fish. So we need a points variable now. All right, let's make that. Variables, rename the default one to points, I guess. And we'll just have it always display by checking it. So points start out at 0 at the start of the game. So let's make the game start when the green arrow is pressed. That starts the game, clears out your points again. Let's do that. Set points to 0 when you click the green flag. So now it's the start of the game. And the idea is the Scratch Cat's going to move left and right, jump up, hit the fish. When he's touching the fish, he gains a point. And then the fish will magically reappear in a new place. And that's the silly game. Okay? So, yeah, so we need to keep track of that points variable. It needs to increase every time we touch the fish. So, let me show you how that works. The fish needs to, also disappear. So let's go to the fishes program now, because when the green flag gets clicked and the program begins, let's have the fish keep checking, hey, is the Scratch Cat touching me right now? Because if that's ever true, we need to give the Scratch Cat points, he wins, he caught the fish, right? So we have no clue how long it's going to take the Scratch Cat to go over and jump up, so the fish needs to be constantly checking, hey, is the Scratch Cat touching me? Hey, is the Scratch Cat touching me? Just like the ghosts constantly checked their should show ghosts variable. So that's a forever loop. Forever, keep checking, hey, is the Scratch Cat touching me? If he is, if the Scratch Cat is touching me, then I'll name him Scratch Cat instead of Sprite1, just for fun. If he is, and here's the condition for that. There's a sensing thing. Look, touching. If touching Scratch Cat. This is true. It's false right now because they're not touching each other. But if they are touching each other, it gives back true. And that will tell us when they have come together. And the Scratch Cat needs to gain points when that happens. All right? So whenever the Scratch Cat is touching the fish, then what needs to happen? Well, the Scratch Cat needs to get a point, that's for sure. So change points by 1. All right? Change points by 1. And then we want him to fly off in a different direction too. So here's the fishes program. And here I am playing the game. If I jump up, as long as the Scratch Cat is touching the fish, he's going to get points. Whee! And so it looks like for about 7 frames, the Scratch Cat is touching the fish. If I restart. See how the points goes up by 7? We want it to go up by just 1. So we're going to have to fix that in just a second. But let's do some other things first, and that'll actually solve it anyway. So the reason this is happening is because the Scratch Cat is touching the fish for a while. For 7 frames, apparently. And so it's going up by 7-ish each time. So we want that to only happen once. And so one way to solve this problem is the second the Scratch Cat touches the fish should just disappear and teleport to a different x coordinate. Because we want the fish to randomly appear over here, along this same line. So just change the x, just like left and right, change the Scratch Cat. Don't make the fish go down here or anything. Just keep the fish along this line. Just make him magically reappear over here, things like that. All right. So, yeah, that's the idea. So change points by 1, hide myself. Then the fish disappears. He goes to a random new x coordinate. So that's going to be set x to some random number between, that's a good one. He was negative 150 and positive 150. How about that? So a random x coordinate between negative 150 and positive 150. Go there, Mr. Fish. And then show yourself. All right. So if you remember, blocks in Scratch, they happen immediately. So hide, set, teleport, show is just going to happen in the blink of an eye. So if we want the fish to actually be hidden for a second, we have to wait a little while. So let's do that. Let's wait a second before you teleport and show yourself. Okay? That's going to be the idea. And I think that will be a good game. So if I jump up, he gets 1 point. Then the fish hides, waits a second, picks a new random spot, and shows himself. And the fact that he hid immediately when he first touched it, when we first touched the Scratch Cat, when he first touched the Scratch Cat, that means he's only touching him for a frame. So the points is only going up by 1 each time. Does it make sense why this program works? So every time the fish is constantly checking. This is a forever loop. If I'm touching the scratch cat, then do all this. Increment the points, hide myself, wait a second, pick a new random x coordinate to go to along this line, and then show yourself. And now we're ready to keep playing the game. Okay? So that is how the program works. And you can stop it, restart it, and that resets the points because that's what the scratch cat is doing when the green flag gets clicked. But the fish is just forever checking if the scratch cat is touching him. If so, he needs to give points to the scratch cat and teleport somewhere. Any questions about this after the explanation? Let's see what else. Yeah, I think that's what I wanted to say. Is there anything else that could be added here? Yeah, technically. You'll have to worry about touching again. Like, check, am I touching? If so, I don't want to like fall through it. That would be another thing that you could do. And this will be part of your next programming assignment, so you could add that if you'd like. Let's see the point. We got the points. We got the movement. Oh, how about this? If I stop the game at a weird spot, watch. Boop. The scratch cat is in a weird place, and the fish is gone. And we'll never be able to touch a hidden fish. So how about we start things off in a certain way? Like the scratch cat starts. We need to initialize the scratch cat here, maybe. Go here in the middle of the screen, and then the fish should always be shown. Just in case you stop it at a weird spot. Okay? Because then you can restart the game, and then it's all like normal. Whee. Yeah, that's a bit better, I think. Now you can stop it wherever you want, and it'll always work out. Okay? So that, I think, is the game that I wanted to make. Are there any questions about this code? Of course, I'll give it to you. All right. Let's see what else. Dun, dun, dun. Let me add a note for myself next semester. Okay. So that's all the slides that I wanted to talk about today. Let me next talk about your next programming assignment. So you got one due this week, I think. So here's your programming assignment 2, because they started at 0. It's technically your third one, right? So this one's going to be due on the 9th. So another 1 week programming assignment. So a week and a day from now. And here are your instructions. So if you've never programmed before, you're gonna make your own platformer game now. You can use my code that I gave you as a starting point if you'd like, but you got to do something new. Please implement a Scratch program with these features. So you have to have some character. You can pick whatever sprite you want. It doesn't have to be the Scratch cat. Have your character walk with the left and right arrow keys and jump with the space key. All right, so that has to be in your program. And you should make something cool happen whenever you touch or jump into some other sprite. All right, so kind of what I did today, but you have to pick something new, some new idea. All right, there should also be at least 2 looping blocks in your program. So like a forever block and a repeat block, or 2 forever blocks, something like that. I want you to practice loops in this assignment, and so I want to see at least 2 looping blocks. All right, and so yeah, you can use my demo. I gave you all this code as a starting point, but of course your something cool must be unique. You can't catch some random sprite in the same way the Scratch cat caught fish in my example. All right, you have to do something cool that is brand new. And as usual, from now on, I'm requiring a video. Okay, so please upload a video of your program running. Show me your code, walk me through it, show me an example. You don't have to talk for very long, just 30-second video, 1-minute video, whatever you need to get your point across, show all your code, show me it working. I want you to explain to me that you understand what you're doing. That's all. All right, so that is your program if you're doing the Scratch stuff. Any questions about it? Platformer game. If you have programmed before, here is your alternate assignment. So read these chapters of the book and do these 3 exercises. And just like everybody else, please record a video. Show me them working, show me that you understand the code, stuff like that. All right? So any questions about that? One or the other? And this will be due on the 9th. Okay. Yeah, if we're good, that is all that I have for you. You can use the rest of the time to get started and to ask questions.